Good morning students, welcome to the next lecture. So in this video we will learn about first of all what is scalar quantity and other is the vector quantity. So what is scalar quantity? If we talk about speed, so speed is a scalar quantity, but if we talk about velocity, it is vector quantity. So what is the difference between scalar and vector quantity? Scalar quantity means which tells magnitude as well as which tells us about magnitude, whereas if we talk about vector quantity, so it tells us about magnitude as well as direction. So suppose a body is moving in a circular path. So this is a circular path. This is a circular path. So a body is moving with a speed of, this body is moving in this path and the speed is 50 km per hour. So here at each point of time when the body reaches at this position, let the position be P, here the position is P dash, here the position is P double dash, here the position is P triple dash. So whether the body is at position P, P dash, P double dash or P triple dash, everywhere the speed is same, that is it is moving with a speed of 50 km per hour. So since the speed is same, so we can say that here speed is constant. But if we talk about velocity, suppose this again there is another circular path and a body is moving with a speed of again 50 km per hour. So what we see here, when a body is at position P, comes to position P dash, then position P double dash, then position P triple dash. So as the body changes its position, what happens? The speed is same everywhere. Here also at P dash it is 50 km per hour. Here also P double dash 50 km per hour. Here also same 50 km per hour. But what we see, at each point of time the body is changing its direction. See, here the direction is this, along this path. At position P dash the direction is along this path. If we talk about P double dash, the direction of body is along this path and here at this direction. So what happens at each point of time, the direction of motion of body changes, that is it is tangential. So what happens, since here magnitude is same, but if we talk about direction, so direction is variable. So since magnitude is same, but what is the problem? The direction is variable. So since direction is variable, that means the velocity is not constant, it is variable. Here in this case the velocity is what? Variable. So since speed is a scalar quantity, so we notice only the magnitude. So here the magnitude is constant, so we can say that speed is constant. But here since velocity being a vector quantity, we have to check here magnitude as well as direction. So here what happens, magnitude is same, that is it is constant, but if we talk about direction it is variable. So since one quantity, that is the direction, is variable, so complete velocity is variable. So can we say that is here the velocity is constant? No, here velocity is variable. And you have learnt in the earlier classes that acceleration is the rate of change of velocity. So here what we say, here velocity is not constant, it is changing, that is, it is variable. So here we can say that the motion is accelerated. Now we will talk more about it. Now we will learn about uniform circular motion. So when a body moves in a circular path, so here the speed is constant. So suppose when a body is at this position, the direction of motion is along this. When it reaches to this position, the direction is along this. Similarly, at each position, the direction of motion changes. So from here we can say that here the speed is constant, but direction is variable. And when we talk about velocity, so velocity, that means magnitude as well as direction. So we cannot focus only on the magnitude. Instead, we have to focus on the direction also. So since direction is changing, that is, it is variable, so we can say that velocity is not constant, it is variable. And we know that acceleration is the rate of change of velocity. So acceleration, that means there is some acceleration. Since velocity is changing, so with the passage of time, velocity is changing, so the motion is said to be accelerated. So we can say that when a particle moves with a constant speed in a circular path, so here the particle is moving with a constant speed in a circular path, its motion is said to be uniform circular motion. So this motion, we can say that it is uniform circular motion. So in such a motion, the particles travels equal distance in equal interval of time. So what happens? The distance covered, the particles are covering equal distance in equal interval of time. Suppose we can say that this distance is 10 meter. So time taken for covering 10 meter here will be same as time taken to cover 10 meter here. So that means the speed is same, but the direction is changing, and since the direction is changing, we can say that velocity is variable, and since velocity is variable, the motion is accelerated. So we can say that it is an example of accelerated motion. So always remember that uniform circular motion is a kind of accelerated motion. So now we will learn about what is the difference between uniform circular motion and uniform linear motion. So if we talk about uniform linear motion, so in case of uniform linear motion, suppose a body is moving in a specified direction with a constant speed. Again take the same speed, 50 km per hour, and the body is moving in a straight path. So what happens here? Here the magnitude is same as well as the direction is also same. So there is no change in the direction. That means magnitude constant, direction is also constant. So since magnitude and direction both are constant, so we can say that velocity is also constant. Now, so from here we can say that velocity is constant. Since velocity is constant, that means there is no change in velocity, and acceleration, we know that it is change in velocity upon time. So since there is no change in velocity, that means acceleration is 0. So from here we can say that uniform linear motion is an example of non-accelerated motion. Whereas when we talk about uniform circular motion, so it is an example of accelerated motion. So So what is the basic difference between uniform linear motion and uniform circular motion? That uniform linear motion is an non-accelerated motion, whereas uniform circular motion is an accelerated motion. Now we will talk about centripetal force. So centripetal force is a force needed to change the direction of motion of a particle to change the velocity of the particle, that is to produce acceleration. That means whenever, suppose a body is moving in a circular path, so when the body is changing its direction of motion, so there is always a force which is responsible to turn the body in a specified direction. So the force here responsible is called as centripetal force, and the centripetal force is, always remember that it is directed towards the center. So a particle moving in a circular path continuously changes its direction of motion at each point of time. We can see in the figure that when the particle reaches at different positions, it continually changing its direction. So this change in direction is possible only when there is a force acting on the body, and the force here acting is towards the center of the motion. So it is termed as centripetal force, which is responsible for the accelerated motion in a circular path. We can take the example, the movement of planets around the sun. So what happens when the planets move around the sun? There is an attraction towards the center. The planet is attracted towards the center. So this centripetal force here is provided by the gravitational force of attraction. So this gravitational force provides centripetal force. Similarly, when a stone, suppose this be a stone and it is tied to a string, and when it is moved in a circular path, so we can see that the string becomes tight. So this tightness is due to the tension force. So here tension force is responsible for the centripetal force. So here tension. Now there is another force called the centrifugal force. So centrifugal force is a force assumed by an observer moving with the body. So this is very important, that the observer must be moving with the body. So when there is an observer moving with the body, so he assumes that there is a force which acts on the body in the direction which is away from the center of the circular path. So when there is a motion of a body, so suppose there is an observer which is moving with the body, let it be a merry-go-round. So when here the observer be A, so when the ball is at position P, so as the ball moves, the observer assumes that there is a force which is acting away from the body, and there is a force which is acting towards the body is called centripetal force, and the force which acts away from the body, that is away from the center, is called the centrifugal force. But here one thing to note, that centrifugal force, we studied it acts away from the center. Whereas centripetal force acts towards the center. So always remember that centrifugal force is not the reaction force of centripetal force. Why? Because always remember that action and reaction acts on different bodies. But here we can see that the force which is acting away from the center and the force which is acting towards the center, both forces are acting on the same body. So always remember that centrifugal force is not the reaction force of centripetal force. And centrifugal force is also known as pseudo force. Pseudo force means the force which is not true, or we can say the fictitious force. So this force actually does not act, but it is assumed by the observer. So it is called pseudo force or the fictitious force. So we will talk about the cases, the two different cases in the next video. Thank you.